This is still less than 7-5. Now we're in example 5 where you have two rational exponents. We're going to solve this and check for extraneous solutions. Now I have two expressions that have rational exponents. What I want to do is get one on each side. So I'm going to add this expression to the right side. So we get x plus 1 to the 2/3 power equals positive 9x plus 1 to the 1/3 power. Now the concept is always going to be raise both sides of the equation to a power that will make you have integer exponents. That way you can expand stuff out and collect like terms and then factor if necessary. So because the common denominator in this case is 3, I'm going to raise both sides to the 3rd power. So 2/3 times 3, the 2 is going to survive, so it's going to be x plus 1 squared. This side, 3 times 1/3 is just 1. So just the 9x plus 1 drops out by itself. Now we have to FOIL out this again, x plus 1 times x plus 1. So let's do this real quick. This is x squared plus 1x plus 1x is plus 2x and then plus 1. Okay, so then we have to subtract 9x from right here and we have to subtract 1 from right there. This is going to make this side 0, which is what I want. So we have x squared, 2 minus 9 is minus 7x. Aha, the constants cancel out, which in this case is actually pretty neat. It makes our job a lot easier. I just have a binomial with a GCF. The GCF is x. So I factor out 1x and I'm left with x minus 7 equals 0. This is easy to figure out with the zero product property. The 0 from this one is 0. The 0 from this one is 7. So we have x equals either 0 or 7 or both. Now, we're not going to go through all of this procedure again because it's up to you to figure this out on your homework. But if you were to plug both of these back into this equation, they both would work, so they're both the answer.